All right, so in this warm-up, the first step that we need, so the first thing that we would need to do in this warm-up is we would need to find the legs of this right isosceles triangle, right? We need to find the legs because those serve as our base and our height, and those are the only two segments we need for the formula. So we know when we have a right isosceles triangle that the pattern is x, x, x root 2. Good. So we need to do 6 root 7 divided by root 2. Then we, of course, do our favorite thing, which is rationalize the denominator. So we have 6 root 14 over 2, which reduces to 3 root 14. We okay there? So now we use our good old triangle area formula, and we do base times height divided by 2. What I want you to do is multiply all the integers first. So 3 times 3, 9. Now multiply the radicals, square root 14 times square root 14. Those square roots will cancel. And so we have 9 times 14. How pretty did that turn out? Divided by 2, yep, which is really just 9 times 7. So the answer is 63. We don't know the units, so we can just write u squared. Very nice. All right, this is an extra formula. This one is not on your formula chart, so if you did want to use this formula, you would have to memorize it. Now, so equilateral triangles come up a lot, not just in our geometry unit, but in the real world. So every time finding the height using 30, 60, 90, you don't have to do that every time. We have simplified it, and there's a formula out there that can help you find the area of an equilateral triangle, and all you have to know is the side. Okay? So we could derive the formula, but I'm not going to. You can probably derive it on your own. But the formula, if you want to write this down in your notes, is side squared root 3 over 4. Side squared root 3 over 4. This will quickly and easily get you the formula, the area, of an equilateral triangle. And it helps you avoid doing this whole thing. 1/2 s root 3. You know how you find this is 1/2 s, and you do all that, and then you do base times height divided by 2. It just helps you skip that step. Let's try a couple. So remember, if you're going to use this formula, you do have to memorize it. But it's useful, it really is. Side squared root 3 over 4. So side squared root 3 over 4. So the area of that triangle is 9 root 3 over 4. Side squared root 3 over 4. 121 root 3 over 4. And I obviously don't have an example where the numerator is divisible by 4, but if it was divisible by 4, you would need to move on and simplify that before you submit a final answer, okay? Today's lesson is trapezoid, rhombi, kite. So title your note. We're going to dive right into the formula of a trapezoid. You find the sum of the bases, base 1 plus base 2. Multiply by the height of that trapezoid and divide by 2. It looks a lot like the formula for triangle, base times height divided by 2, except it's just the sum of the bases times the height divided by 2. Because a trapezoid is really just a triangle with its head cut off, right? So that's why it makes sense that the formula is very similar. All right, let's see if we can do some trapezoid problems. Go ahead and try this one. Find the area and perimeter of the trapezoid. Before you do it, I actually want to change something. There. I don't want that to be 10 for a reason. Okay, now you can solve this one. Alrighty, to find the area of this trapezoid, we definitely need a height. So I hope everyone drew a height in there. We know the formula is base 1 plus base 2 times the height divided by 2, right? So have we gotten the height? What did y'all get for the height? Very good. The height is 10 root 3. So we have base 1, we have the height, now we need base 2. This one is, of course, 10, right? 30, 60, 90, 10, 10 root 3, 20. In this part, we take the 12 and we're allowed to translate it directly below. And so base 2 is 22. Are you okay with this? Now we go straight to our handy dandy formula. Base 1 plus base 2 times the height divided by 2. What we're not going to do is put that whole thing, including the root 3, into our calculator. We are not going to do that because that takes our answer, remember, from exact to approximate. And we're exact kind of people. We're not approximate kind of people. So what we're going to do is if you need to, you can put the whole thing except for the root 3 in your calculator. And then you can attach the root 3 back on. Or you can do it in your head. 12 plus 22 times 10 divided by 2. So, do you agree? 170 root 3 centimeters squared. And then, of course, the perimeter. We do need to be a little bit careful on the perimeter because although you're allowed to multiply a radical by an integer, you're not allowed to add a radical and an integer. So we are doing 22 plus 12 plus 20, 54 plus 10 root 3 centimeters. No, you don't combine those. No, it's not 64 root 3. Yes, you keep them separate. Next problem. Find the area of the trapezoid, round to the nearest tenth. Ooh, now that's a clue. When you see round to the nearest tenth, Miss Tanton does not like rounding. I despise rounding because it makes us approximate, right? But when you see round to the nearest tenth, that means I had no choice. And the only time I have no choice, good, is trigonometry. I'm going to let y'all work on this for a little while before I go over it. All right, we know that to begin this problem, we need a height. I actually recommend drawing in both heights, both altitudes, because we will use both of them in this problem. Okay, so we know we need base 1, we need base 2, and we need a height. All we have so far is base 1, so we've got some work to do. Let's work in the easier section of the trapezoid. Let's work in the 30, 60, 90 triangle. So we know we've got 30, 60, 90 because we drew an altitude. We know across from 30 will be half of 44, and across from 60 will be half of 44 root 3. So we've solved that triangle to its fullest. We know we can take this 56, and we know we can translate that down like this. So this is 56. And now we have to work in the dreaded trig triangle. I'm calling it a trig triangle because 55 is not a special angle. It's not 30, it's not 60, it's not 45. So we do need to use some trigonometry to find this value right here. We've got opposite and we've got adjacent. That is tan. Tan 55 equals opposite over adjacent. Then you ask yourself, where is the variable? Denominator. Denominator divide. So you go to your handy dandy calculator and you do 22 divided by tan 55. You get a decimal, right? Does Miss Tanton want you to round that decimal? No, not yet. We don't round until the end. We don't round until the end. We don't round until the end. So it's like 15.404556. That should be enough. Technically that 6 is a 7, but that's enough decimal places. Okay, we are ready to go to our formula. It's going to be a bit long. Base 1 plus, I need to add up some segments. I need to do segment addition so I can find base 2. So I'm going to do my 15.40456 plus 56 plus 22 root 3. In this case, you do put the radical in your calculator because we are rounding to the nearest tenth. So you do put your radical in the calculator. I'm getting 109.5097, something like that. As long as the first two decimal places are the same, we're okay. Base 1 plus base 2 times the height divided by 2. So it said to round to the nearest tenth, so let's follow those directions. 1,820.6 inches squared. We are moving on to how to find the area of a rhombus. This might be the only formula that you haven't seen before. You've probably seen trapezoid, rectangle, parallelogram. You've probably seen all of that before. Here is a brand new formula for you. In the formula for the area of a rhombus, we are using the diagonals. We are finding the product of those diagonals and then dividing by 2. So the formula, those D's stand for diagonal. Diagonal 1 times diagonal 2 divided by 2, where the diagonals are those dotted segments. It works a lot like the area of a triangle. Base times height divided by 2. Diagonal 1 times diagonal 2 divided by 2. It looks the exact same except the variables are called different things. Let me tell you a mistake that people make. For some reason, look at diagonal 1 times diagonal 2. Those letters are next to each other. Does anybody see a plus sign? Does anyone see one? No, because there is not a plus sign. And for some reason, students do diagonal 1 plus diagonal 2 divided by 2. That is not the formula. Don't add them. When you see two letters sitting next to each other, it's implied that you multiply. All right, go ahead and try to find the area of the rhombus. All right, diagonal 1 times diagonal 2 divided by 2. We know from our quadrilateral unit that a rhombus is a parallelogram. And a property of a parallelogram is diagonals bisect each other, right? So, one of the diagonals is 12. Okay, now we need to use a Pythagorean triple or Pythagorean theorem to find the other one. 3, 4, 5, you double that, you get 6, 8, 10. So that's a Pythagorean triple. If you didn't know that, you can use the Pythagorean theorem. So diagonal 1 is 12. Diagonal 2 is 16. Find the product and divide by 2. 96 feet squared. Next problem. Find the area of the rhombus. All right, we know we've got a 30, 60, 90 triangle because we know in a rhombus that the diagonals are perpendicular. 12 root 2 is across from 90, so across from 30 would be 6 root 2. So we now have one of our diagonals, 12 root 2. Our other diagonal, let's see, this is x root 3, so x root 3. 6 root 2 times root 3 would be 6 root 6. We know the diagonals bisect each other, property of a rhombus, well, a parallelogram rather. Diagonal 1 times diagonal 2 divided by 2. Okay, let's do all the integers first. 12 times 6 divided by 2. 36, right? Yes, good job, guys. Sorry about that. Nice catch. There's lots of 12s in this, isn't it? 12 times 12 divided by 2. 72. And now we'll multiply our radicals. Square root 2 times square root 6, square root 12. We know that that is not a final answer, so we have to factor tree the 12. A 2 escapes. Oh, we're back at 144 again. And a 3 is left over. So 144 root 3 units squared. You know what the great news is? The kite and the rhombus share the same formula. Woohoo! So the formula for a rhombus is diagonal 1 times diagonal 2 divided by 2. It is the same formula for a kite. It's kind of like part of the reason is because the diagonals of a rhombus are perpendicular and the diagonals of a kite are perpendicular. So, very cool. Diagonal 1 times diagonal 2 divided by 2. Let's try some. We have 2 kite problems and then we're done. Great news about the diagonals being perpendicular is that you're allowed to use Pythagorean theorem, and Miss Stanton usually puts Pythagorean triples in there. So this is 9, 12, 15. This is 12, 16, 20. In a kite, remember, one of the diagonals bisects the other. One of the diagonals is the diagonal of symmetry. All right, so diagonal 1, 24. Diagonal 2, 25. Diagonal 1 times diagonal 2 divided by 2. What do we get? 300. And then the perimeter is kind of silly, but you do need to know a property of a kite, right? Two pairs of consecutive congruent sides. There we go. Last problem of the day. Find the area of the kite. All right, let's dive right into this one because of time. 10 is across from 90, so we've had 5 across from 30. So we've already got our diagonal 1, it's set. Okay. Diagonal 2 is going to be a little bit more messy. This is 5 root 3, and then, oh no, that's not a Pythagorean triple. Everyone okay with this? It's going to get ugly, but then it'll get pretty, I promise. Okay, so 5 squared is 25. Square root of 13 squared is just plain old 13. They cancel. Minus 25. Okay, so I am doing good old Pythagorean theorem. 25 times 13 minus 25. You get 300. Cool. That segment is 10 root 3. The great thing is that is like terms with 5 root 3. So we are allowed to add them. No decimals. No, sir. Diagonal 1 times, not plus, diagonal 1 times diagonal 2 divided by 2. 75 root 3 square units. Are we okay with that?